Entropy, measure of disorder. Entropy is one of the most fundamental concepts in thermodynamics, describing how energy spreads out and how systems naturally evolve toward randomness. Entropy is a thermodynamic property that measures the degree of randomness or disorder in a system. Think of it as a way to quantify how scattered or chaotic the energy and particles are within a system. The more disordered a system is, the higher its entropy. Entropy is represented by the symbol S in thermodynamic equations. It is measured in joules per Kelvin, which tells us how much energy is dispersed per degree of temperature. This unit helps us quantify the disorder in terms of both energy and temperature. The change in entropy, delta S, equals heat transfer Q divided by absolute temperature T. This equation shows that when heat flows into or out of a system, the entropy change depends on both the amount of heat and the temperature at which the transfer occurs. Higher temperatures result in smaller entropy changes for the same heat transfer. The second law of thermodynamics states that the entropy of an isolated system always increases or remains constant. It never decreases spontaneously. This law explains why natural processes have a preferred direction, always moving toward greater disorder and randomness over time. In reversible processes, the change in entropy is zero. These are idealized processes that can be reversed without any net change to the system or surroundings. In irreversible processes, which are what we observe in nature, the change in entropy is always greater than zero, meaning disorder always increases. Let's look at some everyday examples of entropy increase. Hot coffee cooling down loses heat to its surroundings, increasing overall entropy. Ice melting into water is another example where the ordered solid structure becomes a more disordered liquid. Gas expanding into a vacuum spreads out randomly, maximizing disorder and entropy. The key takeaway is that natural processes tend toward greater disorder and maximum entropy. This fundamental principle governs everything from chemical reactions to the evolution of the universe itself. Understanding entropy helps us predict the direction and feasibility of thermodynamic processes.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.